Hi everyone, in this episode we are going to discuss what are the difference between Cognito User Pool and Cognito Identity Pool. So Amazon Cognito offers two key services, user pools and identity pools. Each service distinct pur- each serving distinct purposes. Here's the difference between the two. Cognito User Pools. The purpose is for user management and authentication. For Cognito Identity Pool, the purpose is for a temporary AWS credentials and federated access. Okay, so for the user pools, it's a user directory where users can sign up, sign in, and manage their profiles. User pools handle the authentication process and provide tokens like ID, access, and refresh, compliant with OAuth 2.0, OpenID Connect, and JWT standards, or JOT. I think that's pronounced as JOT. So, key features: user registration and login, password recovery and multi-factor authentication, customizable workflows using AWS Lambda triggers, integration with third-party identity providers like Google, Facebook, Apple, and etc. It provides tokens, ID token, access token, and refresh token to use with your app. So, typical use case, your app needs to authenticate users, email and password, user login. You want to provide a user profile management system. You need tokens to secure access to your backend APIs. So for Cognito Identity Pools, as stated earlier, its purpose is for a temporary AWS credentials and federated access. So it enables users to obtain temporary AWS credentials to access AWS services like S3, DynamoDB, etc. Identity pools can federate identities from multiple sources, including user pools, social identity providers, and SAML-based identity providers. The key features are federated identities, combined identities from user pools, Google, Facebook, Apple, or custom identity providers. Provides temporary AWS credentials using AWS Security Token Service. Fine-grained access control using IAM rules for users. Supports guest unauthenticated access. So typical use case, your app needs to grant users direct access to AWS services. You want to federate multiple identity providers and use the resulting identity for accessing AWS resources. Use different IAM rules for authenticated and unauthenticated use cases. So, how they work together, user pools handle authentication, who is the user, identity pools handle authorization, what can the user do. You can combine user pool with identity pools, authenticate the user with a user pool and obtain tokens. Use the user pool to token to federate the identity and obtain temporary AWS credential from an identity pool. So comparison table, purpose, authentication, for user pool, it's for authentication, identity pool for authorization, token, temporary AWS credential, so OAuth token, integration, social login, SAML, custom providers, federate, and for identity pool, federates multiple identity providers, AWS service access, not directly, provides temporary AWS credentials to AWS services, Sports guest users, no. For user pool, for identity pool, it's yes. Access control, not direct. Um, so identity pool is IAM rules for fine-grained control. Example, user pool only. A user signs into a web app and retrieves tokens for accessing a REST API. Identity pool only. An app allows guest users to upload files to an S3 bucket using temporary AWS credentials. Combine a user signs in with a user pool, and the app uses the token to get AWS credentials from an identity pool. The user can then upload files to S3 or query DynamoDB. Yeah, so this is very confusing. The name is confusing, user pool and identity pool. This should have like a authentication pool and authorization pool, right? So that it will be clearer. Um, let's proceed. Can you use identity pool for authentication? You cannot directly use identity pool for authentication because authentication is not their primary purpose. Identity pools are designed for authorization and obtaining temporary AWS credentials for accessing AWS services. Authentication is usually handled by user pools or external identity providers. Here's how this works in detail. Why identity pool aren't for authentication? No authentication mechanism. Identity pools don't provide built-in mechanisms like username, password, login, or token generation. They rely on authenticated identities from other providers like Cognito User Pools, social login providers like Google, Facebook, or SAML-based providers. Temporary AWS credentials. The primary function of identity pools is to map authenticated or even unauthenticated identities to temporary AWS credentials using AWS Security Token Service. These credentials are then used to access AWS services like S3, DynamoDB, and etc. How identity pools work for authentication. You can to use an identity pool, huh? Yeah, so to use an identity pool, you need to authenticate users first using a supported identity provider. Here's a common workflow: authenticate the user, exchange token for AWS credentials, AWS access AWS resources. Okay, so key takeaway: while identity pools are a critical part of AWS Cognito, they don't authenticate users. Instead, they work with authenticated identities from a user pool or external providers to provide AWS credentials for secure resource access. For authentication, you'll need a Cognito user pool or an external identity provider. So yes, you can use. Can you do Cognito authentication in CloudFront? So yes, you can set up Amazon CloudFront to use Amazon Cognito for authentication, though it requires integration with other AWS services. Here's an overview of how you can achieve this. Use AWS Cognito for authentication, user authentication. Set up a Cognito user pool for user authentication. Optionally, create a Cognito identity pool if you need federated identities or access to AWS resources. So configure CloudFront with Lambda at Edge for authentication. CloudFront itself doesn't natively support user authentication. To integrate Cognito, you can use CloudFront itself doesn't natively support user authentication. Okay, so to integrate Cognito, you can use Lambda at Edge to intercept viewer requests, validate the JWT token issued by Cognito, redirect unauthenticated users to the Cognito-based login page. So you can use AWS Cognito for user authentication. Set up Cognito User Pool for user authentication. Create a Cognito identity pool if you need federated. Okay. Okay, so set up Lambda function like Node or Python that verifies the Cognito JWT token. Extract the authorization header or cookies from the request. Validate the token using Cognito's public keys from the well-known jwks.json endpoint. Then deploy the Lambda function to Lambda at Edge CloudFront distribution. Redirect unauthenticated request. Serve content from CloudFront. Okay, so if my application load balancer is, oh no, if I have a farm of EC2 services in fronted by um, application load balancer where it, it is also being served from CloudFront. Where should I put the um, authentication and where should I implement where should I implement authentication in ALB or in CloudFront? Okay, the choice of where to implement authentication, whether in CloudFront or the ALB or the application load balancer, depends on your specific use case, architecture, and requirements. Here's a breakdown of both options. Authentication at CloudFront. How it works: you implement authentication at CloudFront by leveraging Lambda at Edge or AWS Cognito integration. CloudFront authenticates the user before the request reaches the ALB. Advantages: global scale. CloudFront is a globally distributed edge network, so authentication happens closer to the user, reducing latency. Offload authentication logic. Authenticated traffic is filtered before reaching the ALB, reducing the load on your EC2 instances. Caching. Authenticated users can benefit from CloudFront caching for static or dynamic content. Integration with AWS Cognito. Easier integration with Cognito for Auth 2 and JWT based authentication. When to choose, your application needs global edge authentication to to improve latency and scalability. You use Cognito or other token-based authentication systems that work well with Lambda at Edge. You want to minimize traffic. You want to minimize traffic to the ALB and backend servers from unauthenticated users. So authentication at ALB, how it works, the ALB natively supports OIDC and Cognito for authentication. Okay, so ALB supports OIDC, and Cognito for authentication. It performs user authentication before forwarding requests to the target EC2 instances. Advantages: native support for authentication. ALB directly supports Cognito and OpenID Connect. Integration without additional Lambda function. Simpler configuration to avoid the complexity of implementing Lambda at edge for token validation. Fine grain authentication authorization. You can apply path-based or host-based routing rules on ALB after authentication. Centralized authentication for backend. If CloudFront is only used for caching, the ALB remains a single source of truth for authentication. When to choose, your application primarily serves regional traffic and the ALB is in the same region as your EC2 instances. You don't need global edge authentication but want centralized auth at the back end. You prefer the simplicity of ALB managed authentication. So authentication in both CloudFront and ALB. While it's possible to authenticate at both levels, this is usually unnecessary unless you need an extra layer of security or have highly specific routing rules. Key considerations: performance. Authenticate at CloudFront for global users to reduce latency. Authenticate at ALB if the traffic is regional and the primary goal is backend security. Complexity: CloudFront with Lambda at edge involves more coding and management, and ALB managed authentication is simpler and works natively. Use case example. If you have static content, images, JavaScript, or CSS that doesn't require authentication, handles auth at ALB and let CloudFront cache public resources. If you serve dynamic content that requires authentication, implement it at CloudFront to reduce back-end load. For recommendation, for a scenario where CloudFront fronts an ALB that serves EC2 instances, use CloudFront for authentication if you need global edge coverage, low latency, and better scalability. Use ALB for authentication if you want simplicity, centralized authentication, and minimal additional logic. Okay, so if you want to use API Gateway, how should the architecture change? Okay, so if you want to incorporate API Gateway to the architecture, it introduces powerful benefits like managed request routing, authentication, and integration with other AWS services. Here's how the architecture would evolve. Revised architecture with API Gateway. CloudFront still serves as the global edge layer for caching and improving latency for requests worldwide, routes traffic to the API Gateway as its origin. So in the API Gateway, it acts as the primary entry point for all dynamic requests and backend integration, manages authentication, rate limiting, monitoring, and request transformation. Routes traffic requests to the appropriate backend service, example ALB, or directly to Lambda or EC2 instances. Backend services, option 1, API Gateway forwards authenticated requests to the ALB with distributed traffic to the EC2, which distributes traffic to the EC2 instances in your form. AWS Gateway invokes AWS Lambda function for serverless workloads. Option 3 is AWS Lambda API Gateway directly integrates with your backend, example DynamoDB, S3, or even HTTP endpoints. So Key changes to authentication. API Gateway handles authentication. API Gateway natively integrates with Cognito via OAuth 2 or OpenID Connect or any external identity provider. No need for ALB authentication. If API Gateway performs authentication, the ALB only functions as a load balancer. So implementation details, CloudFront configuration, set API Gateway as the origin for CloudFront, cache responses at CloudFront to reduce loads on API Gateway and backend, API Gateway configuration, authentication, integrate Cognito User Pools for user authentication at JW and JWT validation. Use custom authorization like Lambda functions for advanced auth scenarios, fine-grained permissions, authorization, define resource policies to restrict access based on JWT claims or IP addresses. A backend integration, connect API gateway to your ALB, Lambda, or backend services. So for ALB configuration, if you use ALB behind API gateway, you can disable ALB managed authentication. API gateway handles it. Focus on load balancing traffic among EC2 instances. Why use API gateway? Advances centralized API management, authentication and authorization, serverless options, security, flexibility. Scenarios and recommendation. Scenario 1, high traffic with global users. So the use case is many requests are cached and authenticated at the edge. Solution, CloudFront cache. Caches static dynamic content. API gateway handles authentication and backend routing. Backend API for ALB for EC2 instances or Lambda for compute tasks. Scenario 2, serverless first design. Use case, minimizing infrastructure management. So solution, API gateway invokes Lambda directly bypassing ALB. CloudFront caches Lambda responses for latency and cost efficiency. Scenario 3, traditional workloads, um, existing architecture uses EC2 instances and ALB. Solution API gateway integrates with ALB for EC2. Authentication is handled at API level. So final recommendation, use API gateway as the core layer for routing, authentication, and request processing. Front CloudFront remains the CDN for performance and caching. So let API gateway route requests to your backends, ALB, Lambda, or other services based on your application needs. So if you are using EKS, is there still a need for API gateway? Whether to use API gateway in a setup that includes EKS depends on your architecture, use case, and specific requirements. While API Gateway offers powerful features, it may not always be necessary if you're already leveraging the capabilities of EKS and its ecosystem effectively. Here's a detailed breakdown when to use API Gateway with EKS. API Gateway adds value in specific use cases, so authentication and authorization. API Gateway natively integrates with AWS Cognito OIDC providers and custom Lambda authorization, simplifies token validation, OAuth flows, and user authentication, reducing the need for managing auth logic within your EKS services. Rate limiting and throttling. API Gateway provides built-in rate limiting and throttling to protect your backend services from abuse or spikes in traffic. Request transformation and validation. API Gateway can modify headers, query parameters, and payloads before forwarding requests to EKS services. Built-in request validation against schemas ensures malformed requests never reach your Kubernetes cluster. Serverless integration. API Gateway can route traffic to Lambda functions and integrate directly with other AWS services. DynamoDB is 3 complementing your EKS architecture for hybrid use cases. Public APIs. If your EKS services expose public APIs to clients, API Gateway acts as a managed API layer with features like security, monitoring, and developer-friendly API documentation. So architecture with API Gateway and EKS. When you don't need API Gateway with AKS, existing ingress capabilities in EKS, Kubernetes ingress controllers, AWS ALB ingress controller, Nginx, or traffic can handle. Route routing based on hostname or paths, authentication using OpenID Connect or JWT with annotations or sidecars, TLS termination, secure traffic, and within the cluster. These features overlap significantly with API Gateway's functionality. Private APIs or internal applications. For internet-facing APIs not exposed to the public, you can directly use an ingress controller with a private VPC setup or service mesh. For advanced features like mutual TLS and service discovery, cost efficiency, API Gateway can become expensive at high request volumes due to per request pricing. In contrast, Kubernetes ingress controllers are typically more cost efficient when running in EKS for high throughput workloads. Architecture without API gateway. So CloudFront provides caching and global edge distribution. ALB ingress controller handles routing, load balancing, and optional OIDC based authentication. EKS service directly serve application logic through Kubernetes pods. So ALB ingress controller. Okay, handles low routing, load balancing, and optional. Okay. So key considerations: use API Gateway if you need robust public API management, authentication, rate limiting, usage plans. You want hybrid integration with serverless functions, Lambda, or other AWS services. Your APIs must support third-party clients with developer documentation and SDK generation. Okay, so that's where you will use API Gateway. Skip API Gateway if all your APIs are internal, private, or within the same VPC. Okay, so that is if you're in a big enterprise companies. So Kubernetes ingress controllers already handle routing, authentication, and TLS. Cost is a significant concern and your traffic is high. Final recommendation: public APIs. Use API Gateway to manage public facing APIs and offload auth, rate limiting, and client management. For private and internal APIs, use the ingress controller in EKS for direct, cost effective routing with your cluster. Alright, so that's it. Right. Thanks for listening. See you on the next useless video. Bye. Bye, kids.